Question 1. The central argument for incorporating Boolean algebra in ladder logic design stems from the need to optimize control efficiency. A commercial rooftop unit's ventilation fan should only operate when both the thermostat calls for ventilation and the co-level exceeds a set point unless the outside air temperature is below 35 degrees, in which case ventilation must be disabled regardless. Which Boolean expression best represents this requirement? A. Thermostat in co-high and not outdoor temp 35 degrees. C. Not thermostat in co-high or outdoor temp 35 degrees. Answer. Correct answer A. Explanation. The correct expression follows the logic. Ventilation is allowed only if both the thermostat calls for it and co is high, but not when outdoor temperature is below 35 degrees. Boolean algebra enables control designers to program complex decision trees efficiently. This expression uses De Morgan's theorem and logical precedence properly. ANSYS 5.1 provides guidance on symbol and logic representation in industrial automation systems. Question 2. In light of recent developments, Sarah, a controls technician, is tasked with upgrading REDS to thermistors across a facility for zone temperature monitoring. However, her team is concerned about signal stability and response time. Which of the following statements correctly explains the impact of using thermistors instead of REDS in this HVACR application? A. Thermistors are more linear and have better long-distance signal transmission than REDS. B. Thermistors offer faster response times but suffer from nonlinear resistance and signal drift. E. REDS respond faster but are more temperature sensitive and inaccurate at low ranges. D. Thermistors are immune to electrical noise, making them better for EEC communication buses. Answer. Correct answer. B. Explanation. Thermistors respond quickly but are nonlinear and sensitive to self-heating, making them unsuitable for precise applications over wide temperature ranges or long cable. REDS per IC 60751 are more accurate and stable but slow and more expensive. Thermistors' limitations include need for signal conditioning and calibration to maintain reliability and zone monitoring under conditions. Question 3. Throughout the course of commissioning, at AEA, a chilled water pump technician Mr. Patel observes erratic motor behavior at low frequencies. The drive's control loop uses Pi algorithm to maintain differential pressure in the loop. What is the most likely control tuning issue? A. The integral gain is too low, causing sluggish control. B. The proportional gain is too high, leading to hunting or oscillation. C. The set point is incorrect and the feedback sensor is not reading pressure. D. The VFD is not in auto mode, so manual override is active. Answer. Correct answer. B. Explanation. Overshooting and instability at low speeds typically result from overly aggressive proportional gain. This causes the controller to react too quickly to small errors, inducing oscillations. PID tuning must follow principles outlined in ISA 5.5 and should be empirically adjusted or modeled using system-specific parameters such as lag and dead time for optimal response. Question 4. Considering the evidence a controlled damper actuator is malfunctioning were wired to a building's AC power source through a transformer and bridge rectifier. Upon inspection, voltage appears correct, but the actuator still fails under load. What is the most probable root cause? A. Transformer polarity was reversed. B. Rectifier is producing unfiltered DC with excessive ripple voltage. C. The actuator requires AC voltage, not DC. D. Voltage is too low due to undersized transformer vol rating. Answer. Correct answer. B. Explanation. While a bridge rectifier converts AC or DC without proper filtering capacitors or regulators, the resulting voltage contains ripple which can cause erratic actuator performance. Per ESDD 519 and manufacturer datasheets, DC actuators typically require clean DC power with minimal ripple. Always verify power quality, not just voltage, during diagnostics. Question 5. From a practical standpoint, Mr. Nguyen is troubleshooting why a hydronic loop is not transferring sufficient heat. Despite correct delta T across the heat exchanger, the flow rates are nominal and pumps are verified operational. Which condition is most likely affecting heat transfer efficiency? A. Air entrapment in the loop reducing effective heat exchange surface. B. Excess flow velocity causing erosion corrosion inside piping. C. Incorrect water pH leading to mineral scaling. D. Low outdoor temperature reducing thermal load demand. Answer. Correct answer. A. Explanation. Air in the hydronic system creates insulation barriers at heat exchanger surfaces, reducing effectiveness despite correct flow and delta T readings. ASHRAE Standard 90.1 and 111 recommend proper air elimination methods, including air vents and separators, especially in closed-loop systems. Diagnostics must include checking for gurgling, pressure drop irregularities, or microbubble presence. Question 6. As demonstrated by system trend logs, a SKU HVAC system shows poor humidity control despite accurate temperature regulation. The building uses DEATM with enthalpy-based economizers and hot gas reheat. With DEC programming, logic error could lead to this imbalance. A. Economizer is locked out above 6 diodic dry bulb. B. Reheat coil is not sequenced after dehumidification. C. System ignores dew point sensor values in Ohu logic. D. Code-based demand ventilation is overriding humidity control. Answer. Correct answer. B. Explanation. If reheat does not follow dehumidification, the system cannot warm and recondition the overcooled air used for latent load removal. This results in comfort issues and sometimes condensation in ducts. Per ASHRAE 62.1 and 90.1, reheat should activate post-dehumidification to maintain zone temperature while allowing latent heat removal, often using hot gas reheat or electric coils. Question 7. One might argue that adding pressure switches in parallel across a control circuit improves reliability. However, technician Lisa observes that adding a second parallel switch to a safety circuit disables trip protection. Why does this occur? A. Parallel wiring creates a fail-safe configuration. B. Voltage drops across each switch, lowering trip sensitivity. C. Any closed switch in parallel will bypass the open safety, disabling protection. D. Control logic ignores parallel circuits unless sequential. Answer. Correct answer. C. Explanation. Parallel wiring allows current to flow if any switch is closed, defeating the purpose of safety interlocks that rely on all conditions being safe. For protection, safety switches should be wired in series, ensuring all must be closed for circuit continuity. NEC 430 in NFPA 7's stress proper safety wiring and avoidance of redundant bypasses. Question 8. Examining the consequences of a cooling tower fan failing to shut down after system demand drops, technician Marcos reviews the ladder logic. He finds the fan remains energized even when the fan off contact is closed. What control logic issue is likely the cause? A. A latching relay is maintaining coil energization. B. The output run lacks a normally open stop command. C. A timer delay overrides shutdown. D. The analog input is scaled incorrectly. Answer. Correct answer. A. Explanation. Latching relays maintain coil state until explicitly reset. If logic lacks a proper unlock reset instruction like resol, a dropout condition, the fan remains on ladder logic per like 61131. 3 must include break conditions for latches to avoid run-on conditions, especially in cooling tower sequences that rely on system feedback to disengage. Question 9. The impact of poorly chosen set points in a multi-zone valve system often results in increased energy consumption. What is the primary issue when discharge air temperature set point is significantly lower than required? A. Static pressure in ducts increases unnecessarily. B. Reheat coils are forced to work harder to maintain space comfort. C. Coil levels increase due to reduced ventilation. D. The chiller enters low load conditions, increasing efficiency. Answer. Correct answer. B. Explanation. Low discharge air temps mean valve zones must use more reheat to maintain comfort. This wastes energy, violating ASHRAE 90.1 energy conservation requirements. Optimal set points balance latent and sensible needs while minimizing simultaneous heating and cooling, especially in mixed-use or high-turnover zones like classrooms and offices. Question 10. When faced with superheat values much higher than expected, technician ATMED suspects the TVSV is underfeeding the evaporator. What additional diagnostic steps should be performed before replacing the valve? A. Measure compressor amps for overload conditions. B. Check bulb insulation and thermal contact on the TSV. C. Inspect condenser fan operation. D. Verify return duct sealing. Answer. Correct answer. B. Explanation. ESV performance is governed by proper sensing bulb placement and insulation. A loose bulb or poor thermal contact prevents correct modulation of refrigerant flow. As per RE guideline N and manufacturer instructions, bulb contact location on horizontal suction lines at 4 or 8 o'clock and insulation quality must be verified before condemning the valve. Question 11. By evaluating the performance of a control board, technician Mr. Castillo identifies erratic output voltage spikes damaging connected sensors. The issue is traced to a failed Zener diode in the circuit. What is the primary role of the Zener diode in this context? A. To rectify AC signals and to DC for output power. B. To store charge and smooth voltage variations. C. To limit voltage spikes by clamping to a safe level. D. To amplify weak sensor signals before control action. Answer. Correct answer. C. Explanation. Zener diodes are used in HVAC control boards for voltage regulation and transient protection. They allow reverse current flow when voltage exceeds their breakdown threshold, protecting sensitive components. ESTD 315 and IC 60747 cover semiconductor symbols and operation and failure of such. A diode exposes downstream circuits to damaging voltage levels. Question 12. Focusing specifically on a controls retrofit, technician is Avery must terminate live control wiring in a crowded mechanical room. According to NFPA 7TI and OSHA 1910.333, what must be done before proceeding with any termination? A. Secure the area and post warning signs. B. Proceed with insulated gloves and face shield. C. Shut down the circuit and perform lockout or gout LOTO. D. Use a non-contact voltage tester to check for continuity. Answer. Correct answer. C. Explanation. LOTO procedures are mandatory before working on energized systems unless the documented, justified exception applies. Even control circuits can carry dangerous potential or R. Kennedy. NFPA 7TI Article 120 outlines de-energization and verification steps, while OSHA enforces it to prevent electrocution, burns, or arc flash incidents. Question 13. The correlation between coil performance and air psychrometrics becomes evident when a technician observes low latent capacity during humid conditions. Which air property adjustment would maximize latent cooling in an air handler? A. Increase supply air velocity through the coil. B. Lower the coil surface temperature. C. Raise return air dry bulb temperature. D. Decrease supply static pressure. Answer. Correct answer. B. Explanation. Lowering coil temperature below the dew point increases moisture removal. Per Ashry Handbook. Fundamentals. Chapter 1. Latent heat is removed only when condensation occurs. Latent capacity is driven by air temperature, humidity, coil surface temp, and face velocity. Warmer coils may only perform sensible cooling with minimal dehumidification. Question 14. Upon closer examination of VEV controller sequences, Tanaka notices that changes to airflow set points are not being followed despite adjustments via the BMS interface. The most likely programming-related issue is A. The BMS interface has lost communication with the controller. B. Set point overrides are being blocked by a fixed priority array. C. The actuator is defective and ignoring control commands. D. The is in local mode instead of network mode. Answer. Correct answer. B. Explanation. In BACnet or long workspace DEC systems, writable point use. A priority array where low priority writes are ignored if high priority levels have locked in a value without resetting or clearing the array. New set points from the UI won't take effect. This follows BACnet standard 1352020 and control system architecture best practices. Question 15. With respect to evaluating a rooftop unit's TSV, technician Mr. Omar records superheat of 26 deg that the evaporator exit during full load. What does this most likely indicate? A. The TSV is overfeeding refrigerant, reducing efficiency. B. Flash gas is forming upstream of the expansion device. C. The TSV is underfeeding refrigerant, risking coil starvation. D. The evaporator fan speed is too high, causing poor transfer. Answer. Correct answer. C. Explanation. Excessive superheat indicates underfeeding by the TSV. Too little refrigerant means less saturation in the coil and more sensible heat pickup. This condition reduces system efficiency and risks compressor overheating. I standard 410 and manufacturer charts are used to compare expected versus actual superheat to determine proper valve function. Question 16. The foundation of accurate building pressure control lies in proper pressure transducer placement. Technician is Holloway installs a static pressure sensor near a supply diffuser and reports erratic readings. Why is this placement inappropriate? A. Diffuser velocity pressure skews the static measurement. B. The sensor is upstream of the fan, not downstream. C. Heat radiation from the diffuser interferes with the sensor. D. Transducer wiring requires shielding from RF signals. Answer. Correct answer. A. Explanation. Placement too close to a diffuser subjects the sensor to mixed air turbulence and velocity pressure, compromising accuracy. ASHRAE Guideline 36 and NEB procedures recommend pressure taps 2-3 down the main duct away from fittings, turns, or diffusers. This ensures true static measurement necessary for proper fan control and pressure reset logic. Question 17. Among the various DDC communication failures technician ISTA encounters, a persistent issue arises where all zone controllers drop offline intermittently during peak operation. What is the most likely cause? A. Insufficient BACnet addressing in the controller firmware. B. Excessive bus length or improper termination causing signal reflection. C. Ground loop interference from Noviv FDS. D. Loose power connection at the field panel. Answer. Correct answer. B. Explanation. Long communication bus lines must be terminated properly to avoid signal reflection and impedance mismatch. BACnet MATP has strict limits, typically 1,200 meters per 1,000 feet, and improper termination or shielding degrades communication under load. Refer to BACnet MATP wiring guidelines and IR 485 physical layer standards for design rules. Question 18. The most significant aspect of a dehumidification control failure in a Musier HVAC system is its risk to artifact preservation. Technician ISTA raise FIDE RH above 70% despite the system operating. What system condition most directly causes poor dehumidification? A. Evaporator coil is fouled, reducing latent capacity. B. Set point is incorrectly programmed in Fahrenheit instead of percent. C. Blower speed is modulating too low. D. Reheat coil is stuck in full heating mode. Answer. Correct answer. A. Explanation. A fouled evaporator reduces surface contact area and thermal exchange, impairing both sensible and latent cooling. This is especially critical for dehumidification since surface temps must be below dew point. ASHRAE Handbook. HVAC applications, museums, libraries, and archives section emphasizes tight RH control for preservation environments. Question 19. When considering a BACnet system across multiple VLANs, technician Weber is unable to discover devices on a remote subnet. Which configuration step is necessary to enable proper communication? A. Assign all devices to the same MAC address group. B. Enable BMD, BACnet broadcast management device on both networks. C. Increase the BACnet priority array to level 1. D. Disable port forwarding on the router. Answer. Correct answer. B. Explanation. BACnet uses broadcast messages for device discovery, which don't travel across VLANs or subnets. BMD replicates broadcasts across networks, enabling discovery and communication. ASHRAE 135-2020 outlines the use of BMDS and foreign devices for multi-network architecture. Without this, devices appear isolated and fail to exchange data. Question 20. The underlying principle of suction pressure regulation in A walk-in freezer lies in controlling compressor behavior. Technician Mr. Darby notices the evaporator coil ices up prematurely, although door openings are minimal. Which issue could be contributing? A. The defrost timer is set to too frequent. A cycle. B. The suction pressure control is set too low, extending compressor runtime. C. The high pressure control is too sensitive. D. Condenser fan is cycling off too early in the sequence. Answer. Correct answer. B. Explanation. Low suction pressure increases compressor runtime and evaporator supercooling, often dropping surface temperatures below freezing and causing moisture in the air to condense and freeze. Per Emerson's application guidelines and ASHRAE refrigeration handbook, suction pressure settings must balance capacity with frost control and system efficiency. Question 21. Taking into account a variable air volume (VAV) system where multiple zones report inconsistent airflow despite the damper actuators responding correctly, technician Mr. Hassan suspects a sensor fault. Which diagnostic approach best isolates the root cause? A. Check actuator current draw for signs of mechanical binding. B. Compare airflow sensor readings with manual anemometer measurements at diffusers. C. Replace the zone thermostat to eliminate control bias. D. Reset the DDC controller to clear configuration errors. Answer. Correct answer. B. Explanation. The most effective way to confirm sensor accuracy is to compare readings against a trusted, independent measurement tool like an anemometer. Faulty airflow sensors cause control loops to behave erratically despite actuators working. This aligns with ASHRAE Guideline 36 on sensor verification and fault detection best practices. Question 22. Given the circumstances, a technician installs a control transformer feeding a relay coil on a compressor start circuit. After startup, the relay chatter is audible and the compressor cycles rapidly. What is the most likely cause? A. The relay coil voltage rating is too high for the transformer output. B. The transformer is undersized, causing voltage drop during load. C. The relay contacts are welded together. D. The relay coil wiring is connected in series with the compressor motor. Answer. Correct answer. B. Explanation. An undersized transformer cannot maintain stable voltage under load, causing relay coil voltage to fluctuate and chatter. This rapid cycling stresses components and risks failure. NEC Article 450 and manufacturer guidelines emphasize correct transformer sizing based on VAR load requirements to avoid voltage drop and relay chatter. Question 23. From the perspective of HVAC control theory, a chilled water temperature control loop exhibits slow response and significant offset. Technician Is Garcia proposes tuning changes. Which adjustment should she prioritize? A. Increase proportional gain to reduce steady-state air. B. Increase interval gain to eliminate offset over time. C. Increase derivative gain to reduce oscillations. D. Decrease set point to force faster response. Answer. Correct answer. B. Explanation. Interval gain accumulates air over time and corrects steady-state offset, essential for stable temperature control. Proportional gain affects response speed but cannot eliminate offset alone. Derivative gain reduces oscillation but doesn't correct offset. These principles align with ISA 5.5 and PIG control tuning theory. Question 24. A detailed analysis of a pneumatic actuator shows delayed valve response despite correct air supply pressure and signal. What is the most probable mechanical cause? A. Actuator diaphragm rupture reducing air pressure efficiency. B. Electrical signal wiring damaged interrupting control. C. Valve stem binding due to corrosion or debris. D. Incorrect actuator size relative to valve torque requirements. Answer. Correct answer. C. Explanation. Valve stem binding creates mechanical resistance, causing slow or stuck valve response despite proper pneumatic signal. Routine mechanical inspections per manufacturer guidelines and ASHRAE maintenance manuals help identify and prevent this issue. Diaphragm rupture usually results in no movement, not delay. Question 25. Across different scenarios, an HVACR technician must select a refrigerant replacement for an R22 system that minimizes environmental impact while maintaining performance. What is the key factor to consider? A. The refrigerant's ozone depletion potential op and global warming potential BBD, refrigerant cost and availability in local markets. C. The lubricant compatibility with existing compressor oils. D. The refrigerant's flammability rating and toxicity. Answer. Correct answer A. Explanation. While cost and compatibility are important, environmental regulations such as the Montreal Protocol emphasize selecting refrigerants with low or zero output and rigidity to comply with law and sustainability goals. The ASHRAE Standard 34 classifies refrigerants by safety and environmental impact, guiding responsible replacements. Question 26. When evaluating the merits of an electrical control schematic for a rooftop unit, technician Mr. Jensen notices a missing neutral return wire for the control transformer. What is the likely consequence? A. The transformer will not energize due to lack of return path. B. The relay coils may experience voltage fluctuations and misoperation. C. The compressor motor will run at reduced speed. D. The system's ground fault protection will trip continuously. Answer. Correct answer. B. Explanation. The control transformer requires a complete circuit with both hot and neutral lines for stable voltage supply. Missing neutral can cause fluctuating voltage and unreliable relay coil energizing, leading to intermittent faults. NFPA 70 Article 450 and ANSI wiring standards specify proper transformer wiring for safety and operation. Question 27. Under the assumption that a Lonworks network segment is experiencing communication errors, technician Isabel Patel suspects network addressing conflicts. Which of the following best resolves this issue? A. Assign unique neuron IDs to each device on the network. B. Increase the baud rate to improve signal quality. C. Replace twisted pair cables with fiber optic lines. D. Install additional repeaters to boost signal strength. Answer. Correct answer A. Explanation. Neuron IDs are unique identifiers for Lonworks devices. Duplicate IDs cause communication collisions and errors. Correct addressing ensures proper message routing per ANSI 709.1 standards. Adjusting baud rate or cable type does not solve addressing conflicts, though can help with signal integrity. Question 20. What factors contribute to premature compressor failure in a system using reciprocating compressors, despite proper electrical supply and no visible leaks? A. Overheating due to inadequate lubrication and excessive cycling. B. Incorrect refrigerant charge causing high head pressure only. C. Loose wiring connections causing intermittent power. D. Undersized evaporator coil reducing suction pressure. Answer. Correct answer A. Explanation. Overheating and inadequate lubrication cause internal damage and bearing wear, especially with short cycling that prevents oil return. This aligns with compressor manufacturer guidelines and RE 540 standard for compressor lifecycle management. Proper system design ensures adequate runtime and oil management. Question 29. During the process of commissioning an air handling unit, Choi finds the COS sensor readings fluctuate wildly with no apparent source of contamination. What is the most likely cause? A. Sensor calibration drift due to age or exposure. B. Faulty wiring causing intermittent power. C. Presence of refrigerant gases interfering with sensor. D. High humidity causing sensor condensation and errors. Answer. Correct answer A. Explanation. COS sensors degrade over time and require periodic recalibration. Drift causes inaccurate readings and unstable control signals. ASHRAE Standard 62.1 references regular maintenance and calibration schedules for indoor air quality sensors to maintain accuracy and system reliability. Question 30. As illustrated by a technician's troubleshooting log, multimeter reading across control relay coil shows zero resistance. What does this indicate, and what should be the next step? A. Coil is intact. Check relay contacts next. B. Coil is shorted. Replace relay immediately. C. Multimeter leads are reversed. Retest carefully. D. Coil is open. Verify wiring continuity. Answer. Correct answer. B. Explanation. Zero resistance across. A coil indicates a short circuit, meaning the coil winding is damaged internally and non-functional. This requires relay replacement to restore proper operation. Correct troubleshooting procedures per NEC Article 430 include verifying coil resistance before energizing circuits to prevent damage.